Hello everyone, in this video we are going to learn about voltage sources under DC circuit theory. This is our 12th video on this playlist. Voltage sources. A voltage source is a device that generates an exact output voltage which doesn't change regardless of the load current. So which means the voltage source, it should not change the output voltage value with respect to the load current. So that's what we call as the voltage sources. The voltage source. A voltage source such as a battery or generator provides a potential difference between 2 points within an electrical circuit, allowing current to the flowing around it. Remember that voltage can exist without a current. A battery is the most common voltage source for a circuit with a voltage that appears across the positive and negative terminals of the source being called the terminal voltage. So here, for an example, the voltage and current is something like a water tank. The pressure in the tank or the level of the water is something like a voltage. So here, the pressure of the voltage depends on the height of the tank or the height of the availability of the water. So this is something like, so this is depend on the pressure. Pressure is something like a voltage source. Here the flow rate of the water is something like a current. Normally we can compare this reality with this water tank. So here it is the, normally the voltage is something like to give the potential across the circuit. The flow rate is the current. So for an example, here in the power generation station or power generating station, normally in Sri Lanka, India, Pakistan, normally they are generating current in the 10.5 kV to 20 kV. The generating voltage from the power station is something like lying between 10 to 20 kV. Then they are step up this voltage into 132 kV or 220 kV. So based on their requirement, they are converting or they are step up this voltage rate by using the step up transformers. Mostly they are converting 10.5 into 220 kV, or somehow in old transmission line they have 132 kV line. Then these are the long distance transmission line. Then that is fed with the receiving station. Again they are step downing to 33 kV and again they are transmitting to the distribution division. So here why they are using this high voltage to transmit this voltage. Normally the generating voltage is 10.5 kV. Then they are step up this voltage into 220 kV or 132 kV based on their requirement. So what is the purpose? Why they are step up this voltage? The reason is here the generating station is too far from the receiving station or the consumer home or the supply station. But to transmit over long distance, they need to reduce the loss of the transmission supply. To reduce the loss, they need to step up into high voltage. Therefore, we are using 220 kV for the long distance transformation. So, if we transmit the current or the supply with this level of the voltage, then the loss is reduced or the loss is negligible. Not negligible. In practically we cannot negligible. Comparatively we can reduce the loss. That's why for the long distance transmission we are using high voltage. So here another practical explanation you have to consider is, so here there are some example for the voltage source that we are using in practical life. Battery or generators are the good example for the voltage source. There are so many voltage sources, but in practically we are using battery and generators, normal common life. So here this is the minus terminal of the battery, this is the plus terminal of the battery. So for an example, I am using 10 voltage supply. Then I am feeding with this voltage with a load. So even if the load current is 0, which means even if there is no load current, this voltage level or the voltage should be constant. There should be no changes in this voltage level. Even if the load current is 0, the terminal voltage should be constant. This is what they have mentioned here. Remember that voltage can exist without current. A battery is the most common voltage source for a circuit with a voltage that appears across the positive and negative terminal of the source, being called the terminal voltage. The terminal voltage means the voltage difference in between negative terminal to positive terminal. This is what we call as the terminal voltage. Ideal voltage source. So here are some examples for the ideal voltage sources. So the first one is constant voltage source. The second one is alternating voltage source. The third one or the last one is the constant current source. Okay, what are the difference between these three types of sources? The constant voltage source, which mean here the Vs mean by observing this characteristic curve, you can see that this Vs is in the constant value. It is not varying by all the value of I mean load current, IL. It is the voltage, terminal voltage is in the constant value. It is not changing or it is not varying. Likewise, here alternating voltage source. So we all know this symbol. This symbol is used for indicate the AC supply. So this is the AC voltage sources. So here you can observe by this characteristic curve. At the starting point, it is started. Initially from 0, it is increasing the value from 0 to plus Vm, then decreasing from plus Vm to 0. Again for the negative half cycle, again at the negative half cycle it is increasing from 0 to minus Vm, then decreasing to minus Vm to 0. Likewise, it will continue as the pure sinusoidal wave. So this is for the example for the alternating voltage source symbol. So this is the constant current sources. So here the constant voltage source. The last one is constant current source. So what are the difference in between these two elements? Here by all the value of I, the V is not changing. The V will never change. It will be in constant. But this constant current source here, by all the value of V, terminal voltage, the current will never vary. The current will be in the constant form or the constant value. For an example, here 5 voltage constant supply, which mean for all the value of load current, the terminal voltage will be in 5 voltage. Here 5 ampere current source. For an example, I am considering as the 5 ampere current source. Then for all the value of the terminal voltage, it will produce the same amount of current, 5 ampere. It will never change. For all the value of V, here by increase or decrease, for all the value of V, the I will never change. Connecting voltage sources together. So here ideal voltage sources can be connected together in both parallel or series, the same as for any circuit element. Normally we can interconnect 2 or more voltage sources in series or parallel, but there are some restrictions. So okay, I will explain you what are the restrictions or what are the things we have to consider when we connect 2 or more voltage sources in series or parallel. Voltage source in parallel. Okay, here initially let's analyze about the parallel connection. Here there are two same rated voltage sources are connected in parallel. Then here the terminal voltage is also the same value of the one of its the voltage source. Here 10 voltage batteries, two 10 voltage batteries are connected in parallel. Then the terminal voltage is also the same 10 voltage. For an example, if I connect 3 batteries, three 10 voltage batteries are in parallel, even at that time also this terminal voltage will be 10 voltage. So how many batteries are connected in parallel is doesn't matter, but there should be one restriction. We have to connect only the same rated voltage batteries. If we want to connect 10 voltage battery, then all the batteries should have the same voltage level. We cannot or we can't connect in parallel with different voltage batteries. So I will explain you later. Here the important thing you have to note down is, so how many voltage, how many batteries are connected in parallel is doesn't matter. There should be two restriction or two important thing. Here all the batteries should contain same voltage level. The second thing is it will give the terminal voltage will be the same value of the battery, one battery. So here are battery connected voltage sources. You can see that two batteries are connected, two different voltage level batteries are connected in parallel. So if we connect it like this, it will produce excess heat or sometimes it may burn. So this is not fair. We have to avoid this type of connection. So here if you want to connect two or more voltage sources or batteries in parallel, then that should be all the batteries or all the voltage sources should be the same value. Here there are two different values, so this should be avoided. Here is another type or battery connected type. Here they have shorted this two terminal of the voltage source. So if we shorted the two terminals of the voltage sources, then it will produce excess heat on this part. So that heat may burn or lead to blast, or it may affect to the person. So whatever it is, it may make a severe injury. So these two type of connection should be avoided. Voltage source in series. So here we can interconnect two different type of batteries or different voltage level batteries in series. So it doesn't matter, but depend on our connection, the circuit may be the voltage addition or the voltage subtraction. So here you can see that they have interconnected this 10 voltage battery with 5 voltage battery. But if you see the polarity, here these two batteries are in the same polarity, connected in the same polarity. Here minus, then plus, connected with this minus, then plus. So here plus, here minus. So in between two terminal, the terminal voltage will be the addition of the two values. Here 10 voltage plus 5 voltage will be 15 voltage. Therefore the terminal voltage will be the addition of the voltage sources. So that means 15 voltage. Likewise here also they have connected 10 voltage in series with this 5 voltage, but the polarity is interchange. Here they have connected this positive terminal with this 5 voltage positive terminal. Here this is minus, but here we have to consider plus. Here also minus. So at this time even we can connect like this. There will be no effect or no any other injuries. We can connect this. This is the fair connection, but here the voltage will be subtract. Here 10 voltage plus minus 5, then the terminal voltage will be decreased. It will give the subtract value of the voltage sources. Here it will give the 5 voltage. Here it will give the 15 voltage. Voltage source example number 1. Two resistors aiding ideal voltage sources of 6 volts and 9 volts respectively are connected together to supply a load resistance of 100 ohms. Calculate the source voltage Vs, the load current through the resistor IR, and the total power P dissipated by the resistor. So for this circuit we have to calculate the source voltage and IR and power. So here two batteries are connected, but they are in different voltage level. Here V1 is 6 voltage, V2 is 9 voltage. These two batteries are in series connection. Now we have to calculate the source voltage. Source voltage means the terminal voltage. Here in between these two terminal, here we have to add these two values because here this positive terminal connected with this other battery is negative terminal, then here the positive and here is the negative. So we have to add this circuit, or you have to consider the addition. So the Vs will be equal to V1 plus V2. Here V1 is 6 voltage, V2 is 9 voltage. So that will be equal to 15 voltage. So the Vs we have found as 15 voltage. Then we have to calculate the load current. The load current, here the load is 100 ohm resistor. So through this load, the load current IR will be, according to the Ohm's law, IR will be equal to V over R. Here V is the Vs, supply voltage, over R. R means RL, load resistor. So here Vs is 15 voltage. Here we have calculated previously. So now we can directly substitute Vs as 15 voltage, RL as 100 ohm. Then if we solve this, we will get the value 150 milliampere as the load current. Then we have to find power dissipated by the resistor P. P will be equal to V into I. So another equation, I squared R. We have learned three equations. P is equal to Vi, P equal to I squared R, or P is equal to V squared by R. So we know the load current, we know the load resistor. Then by this equation we can easily find the power dissipated by the resistor. Even we can use this resistor also, but here we have to put Vs into IR. So whatever equation we are taking, it doesn't matter. If so, all these three equations will give the same value. So here we are using P is equal to I squared R. Here I mean load current. Load current 150 milliampere. So here we have to put the ampere range. Here it is in the milliampere. So it will be 0.15 ampere. So 0.15 into square into 100. That will be equal to 2.25 watt. So very easy question. Okay, let's learn about the difference between practical voltage sources and ideal voltage sources. So what is the difference between practical voltage sources and ideal voltage sources? So before analyze about the difference, now let's learn about what is practical voltage and what is ideal voltage. Practical voltage source means practically we are using in our entire life. For an example, batteries, generators, like this. These types of elements we can consider as the practical voltage sources. But what is ideal voltage sources? Ideal means that voltage source should be in the ideal condition. For an example, here this is the symbol for the practical voltage source. This is the symbol for the ideal voltage source. So what is the difference in between these two symbols? Here there is one and only difference is, here there is an internal resistor R, but here there is no internal resistor. That is the main concept. That is the main difference between practical voltage sources and the ideal voltage sources. So now let's learn about, or let's analyze about, what is that internal resistor. Internal resistor is nothing but, normally in our practical life, I am considering a battery as a, for an example, I am going to consider a battery as our voltage source. So this battery has two terminals. This is minus terminal, this one is a plus terminal. In the practical life, or in the practical situation, in between these two terminals there will be some value of resistance. So that resistance what we call as the internal resistance. So but for the ideal condition, that resistance value or that resistivity value should be negligible or it should be zero. Mostly it should be zero, but in practically that should be negligible. So this is the main difference in between practical voltage sources and ideal voltage sources. Practical voltage source characteristic. So here is a diagram or circuit diagram of our voltage source. Here they have marked as RS. So what is RS? Here the RS is the internal resistor, because here we are dealing with the practical voltage source, not the ideal voltage source. Here the practical voltage source contains the internal resistor. So that resistor we have marked as the RS. So this is a resistor, something like a resistor. So you can see that from this voltage source, here the output current will flow. So here there will be a voltage drop. So here there will be a voltage drop. So from where it is taking for the voltage drop? So from where that is taking supply from the voltage drop? From the supply. So it is taking some amount of voltage from the supply. So here there will be a losses in the supply voltage. Here there will be a losses in the supply voltage. That is we are calling as the practical voltage source. Here normally in the practical voltage source, if we observe the characteristic curve, if because of this RS, here the Vs will be decreased like this. There will be a slope on the characteristic curve. So why it is like this? The reason is here the RS can be vary. The voltage drop across this resistor, this depend on the load current. So when the load current increasing, when I is increased with time, then because of the increment or because of the increase of the load current, the voltage drop will be also increased. So the loss will be here increase with the time or the load current. So therefore here is the slope. So I hope you will clear with this voltage source. In our next video, let's learn about the current sources.